Alright, so I'm gonna briefly talk about option 2 for the assembly, which is this degree of freedom maps. And so what we're gonna do is we're never gonna assemble, so never assemble R and K. Directly assemble this R star and K star. So I don't need to ever create the entire K that is size 8 by 8, right? So the size number of nodes by number of nodes. I don't need to do that because I already know that some of the nodes have essential boundary conditions. So what I can create is I can create a map that assigns for every node the corresponding row and column of the residual, right? So let's keep this mesh actually that I have here, not the previous one. So consider again this. And so what we can do is we can assign this DOF map or degree of freedom map. Where what we're gonna do is for node 1 is in the essential boundary condition, so it doesn't get assigned, so this shouldn't get mapped to the R star, right? So let me just say that the degree of freedom is -1. Node 2 is actually a node that doesn't have an essential boundary condition, so I'm gonna name that my first degree of freedom. Then node 3, I'm gonna assign that my second degree of freedom. Node 4, it has an essential boundary condition, so I shouldn't assign a degree of freedom to that, or not a number. Like I tend to use this -1, but you can choose whatever, right? So this one basically is not defined or something like that. So it doesn't apply. I don't need a degree of freedom for this node. Number 5 would be 3, my third degree of freedom. Number 6, again, I don't need. Number 7 is 4, and number 8 I also don't need, right? So I created this DOF map, this degree of freedom map. So I can use this map to assemble the R star and the K star directly. So I don't ever need to assemble the full R and then isolate the rows of that I'm interested in. So now consider again element residual and tangent. So for E equals 1, I have my residual of the first element, and let's say, whatever, 1, 2, 1, 2. That's the value of my residual. And I need to say what is element 1, what is element 2. Let's say this is element 1, this is element 2, 3, 4, 5, kind of similar to before. Element 1 is made out of nodes 1, 4, 3, 2, and element 2 is made out of nodes 6, 5, 3, 4. Element 3 is made out of node 7, 5, 6, 8. Element 4 is 7, 8, 1, 2. And element 5 is 2, 3, 5, 7. So element 1 is made out of nodes 1, 4, 3, 2, as I defined it. Right? So this doesn't matter. This is just however it appears in the definition, this is how you write them here. But now, instead of assembling, so what I did before is I assembled directly to the R, right? But now I'm going to assemble to R star. So R star is no longer size number of nodes, but it's actually degree of freedom. So let me use this. So it's actually 1, 2, 3, 4 of the, maybe I should just use a different color. 1, 2, 3, 4. So 1, 2, 3, 4 directly. So these are degree of freedom directly, right? And so now I need to be careful because node 1 doesn't necessarily correspond to the first row of R star. I need to pass them through this dov map, right? So when I do that, I see that node 1 goes to nothing, node 4 goes to nothing, right? Node 3 goes to 2, so this one goes to 2, right? Because that comes from these maps right here. So 3 goes to 2, so that means that here I would add this 1, so plus 1 of this entry. So this one actually gets mapped. And then number 2 goes to so this one gets to 2, and number 2 goes to 1. So this one right here goes to here. So you see that now I can assemble directly from the element residual to the R star. So I can do that for, let's do R of 2. So the residual of 2, let's say that this is again, -1, -2, 3, 1, some random numbers. So the second element is made out of nodes 6, 5, 3, 4. So again, similar to before, I'm not going to assemble to the global R, I'm going to assemble to the R star. So 6 goes to nothing, 5 goes to 3, so this one goes to 3. So that means that I haven't used it before, so this one goes to here, so -2. Then 3 goes to 2, so that one I've used before, so let me just do, so this one will go to here, so I'll have +3, because as I said, this one goes to something, and 4 goes to nothing, right? Yes, 4 goes to nothing. So this one went to 2. So that's the way of doing this for this dov map, and so on. So you would do that for every element, and then for the similar for K star. So again, you will go from basically the K of the element, and then you will need to use this map of the node to the degree of freedom to go to K star. And that's it, that's the other option. I tend to use this one whenever I code something. Just because you don't have to assemble the entire system, you just assemble directly the R that you need and the K that you need. Solution is the same, because once you have R star and K star, all you need to do is the iterations with R star and K star. So yeah, all of the options are equivalent. Right. So I'll create one more video actually, where I will try to, so this video and these notes were supposed to be just the assembly. So I'm gonna create one more video with the solution of